Okay. Hey, this is my first video I've ever tried filming, my first tutorial. So I hope this works out for you, and you can give me some feedback and let me know. Thanks. Hi, this is Randy Oliver. I've been working on this Varroa model for some time and like to help you be able to use it. What I found is just to open it up and try to start using it in Excel is maybe a little tricky for some of you. So I'm going to walk you through step by step how to use this. I found this model very useful in understanding Varroa and understanding how to manage Varroa in my operation, and I hope it's of use to you. All right, here it goes. Okay, I'm going to try to walk you through from the very beginning right here. So right now, if you want to download the model, if you type in Randy's Varroa model, I popped up there. You can hit enter, and your search will come up here to scientific beekeeping. You can click on this. And that should open up this page here. Down here is the link, and I will update this link all the time to keep the current version. So you can see this is September 23rd right here. I'm going to click that, and you can name it whatever you want now. So I'm going to write Varroa model, and I'll save it up to my desktop here. Click save. Okay, you won't have to replace it on your first one. Now down here, it'll download. You can click here, and you can click open. It will then open in Excel. And now you can go down to Excel, and you should have it opened in Excel. Now, at this point, what you want to do is enable editing so you can use the model right there. Now it's enabled. Then what I would suggest is go down to your screen sizing. I would put it at 90% view right here. You can use the negative arrow or the positive sign to make it larger or smaller, but 90% will let you have a good view. And then go up to view, click up here to view, and then to full screen. And the full screen view will allow you to see this stuff you don't need to use right now, but it'll let you see the treatments and stuff. Now, what I'm going to do here is I'm going to escape this. I'm going to go back to a larger view here, just for the purposes of showing you this right now so we can see it a little bit better. And I'll scroll up to the top of the page and I'll scroll to the bottom. Now the text is a bit larger so you can see it. What you're going to do now is to look at the cells that you can enter in. Any yellow cell is a cell that you can enter in. And for your instructions, so let me zoom over here to the left all the way, the basic instructions here. This is really, for Joe Beekeeper, all that you will generally need to do is to fill in a value for these three cells right here. And you can read the instructions for these right here. Okay, so you're going to put in your starting mite level right here. And I typically would just start with 100 mites to make it easy here. Your colony type I will talk about later, but the D value for default works well here. And then a mite immigration value. Mite immigration is mites that are coming in from drift from other hives or from your bees robbing out, dying out hives. So you can set the value here for it to 0. And when you hit enter, it will, you just saw it can adjust the lines right here. So if you were totally isolated, one single isolated hive where there'd be no drift from other hives, that would be a 0 value. If you were in a urban area with just tons of first year treatment-free beekeepers and all their colonies crash in the fall, you could have a value up to like a 4 value right here, and you can see you get this large mite load coming in. Watch, I'll drop this down to a 0. You can see the effect of having the mites coming from outside. In general, I find is a value of about 1 or 2 for my operation works for it here. Then what you want to do is you always want to check this value here, the R value. This is the intrinsic rate of reproduction for the mites. And what it does is calculates it for each different 15-day time period over the course of the year. And what this value is, this is the average R value of mite increase from the middle of May to the middle of September. And this can be compared to R values that have been gathered by researchers throughout the world down here. So here's R values from literature. And typically the values are 0.017 to 0.021. If you have strongly mite resistant bees, you can get clear down here to the single digit values. And this is what I'm looking for in my breeding program. But right now, I would stick with something about 0.020. And I'll talk later about how you can adjust that, because that can be adjusted with some of these here. But this is more for advanced use. So I just stick right here. Now, if you are a beekeeper in the Southern Hemisphere, Australia or South America, right here, click an X in here and watch the dates here when I hit return, enter, and you can see the dates all just reversed. So now you have instead of starting in January, you're starting in July right here. Okay, so I'm going to clear that out, delete on that one. And then we'll get to colony type later. So what I do right now is let's take a look here. I'm going to go to the side here. Let's go to necessary mite reduction. And I'll scroll up here a little bit. And again, any of these yellow cells you can change. So you can put in your different R value here for your rate of increase and also for your mortality rate when the mites are not rearing brood. And let's put in a value for how many months they're rearing brood. So let's just say that the mites in your area, the bees in your area, were rearing brood for 5 months of the year. And you started with 1 mite in the hive. You will get up to a peak of 23 mites at this point. And then as they died off from natural mortality, you drop down to 8 mites. If you start with 1, you end up with 8. That's not sustainable. So that means you have to reduce those mites, or you have to split your colonies into 8 colonies the next spring in order to be sustainable. So if you put in 90% mite kill somewhere, you could drop it down to 1. So 1 treatment a year would be enough. And on these squares here, on logarithmic curves, it doesn't make any difference where you put that treatment. Now, in real life, it can make a difference, but not much as to when in the year you do a treatment. So let's delete that treatment here. And let's just say you're in a more normal area where maybe your bees are have a 4-month break without brood rearing during the winter, and then they rear brood for 8 months of the year. And when you can take a look right here, you're going to start with 1 mite. You're going to wind up with over 150 mites from that one over that course of the 8 months of brood rearing. And they'll drop down to maybe 85. So clearly not sustainable. You start with the 85 mites. You start with 1 mite in year 1. Next year, you're going to start with 85 mites. Well, your colony might survive year 1, but it's not going to survive when you start getting larger numbers. Typically, if you're starting with over 100 mites, your colony is not going to survive the year. So what you'd have to do is put in a treatment. So let's say a 90% treatment. That's not quite enough. We'd have to go for, say, a 95% reduction. And that takes it still not quite enough down there. You're going to have to do 2 reductions. So you might have to do like a oxalic acid dribble, and now you get down to 1. So now you're back down to sustainability. This has to come back to 1. You got to get your mite level to the end down to the baseline. Okay, and I can just drag this and hit delete, and that clears them all off. Now, let's say you're a beekeeper in California, where I live, and we have 11 or more months a year of brood rearing a year. And our mites just go totally out of control here. we can have 1,000-fold increase in our mites and very little reduction. Typically, commercial guys would, in the springtime, they'd do a 95% amitraz treatment and another 95% kill or reduction of the mites here. And that gets you down to close to baseline. So if you're splitting your colony in half each spring, that would be sustainable, 95% kills. In reality, a lot of them aren't getting 95% kills anymore. So let's just say you're getting an 80% kill here. And I'll do another 80% kill here. And we're still not there. Another 80% kill here. And maybe we better do another 80% kill. And now you're getting down here. So as the efficacy of your treatments falls, either the failure of the miticide to control varroa, or it could be inappropriate use of that treatment, not putting it in the middle of the brood nest could affect this. So basically, you can use this to figure out what kind of overall mite reduction you're going to need to have in your particular area. Okay, that ends the introduction. open up the next one for using the model.